In this video, we are going to discuss about another application of depth-first search called topological sort. Often, we represent event with precedence with a directed acyclic graph, and we can arrange such a graph in a topological order which will emphasize the precedence among events. We can view a topological sort of a directed acyclic graph as an ordering of its vertices along a horizontal line so that all the directed edges go from left to right. For example, this graph represents the order of wearing clothes arises when John gets dressed in the morning. Now, John must don certain garments before others. For example, John has to wear socks before wearing shoes, or he has to wear undergarments before put on the pants and the shoes. Now, some items may wear in any order. For example, socks and pants. You can either wear socks before pants or after wearing pants. Now, if we order this event in a topological order, it will look something like this. Now, the constraint for this ordering is that if there is an edge from U to V, then U must appear before V. For example, here socks appear before shoes since we have an edge from socks to shoes in our graph. So in our graph, we have an edge from socks to shoe. Therefore, in our ordering, socks appear before shoes. Now also notice that shirt appear before tie because we have edge in our graph from short to tie. Now some vertices or events in our graph may appear in any order. For example, here watch is appear at the middle of the sorting, but it can appear in anywhere in this sorting. It can appear at the beginning, it can appear at the end, and it can appear anywhere in this sorting. Now let's see how can we use DFS or depth-first search to arrange our graph in this topological order. Now notice here that our graph is directed acyclic graph. We define topological ordering only for directed acyclic graph because if there is any cycle, which means that there is no particular order we can refer to. Now in the DFS, we know that if there is an edge from U to V, then V will go to finish state before U go to finish state. So if we push vertices in front of a list as those vertices go to done state in DFS, it will look like the below table. Now in this list, we can guarantee that U will appear before V because in the DFS we know that V is going to done state first and we are pushing item to the list from front. Hence from start, U will appear before V in this list. Now this is the point that we are going to exploit to order our graph in a topological order. Now let's see the pseudocode for our algorithm. Actually, it's very simple. We are going to run DFS on our graph, and when each vertex is finished, we are going to insert it onto a front of a list, and then after all DFS call returns, we are going to return the list, and this list contains the vertices in topological order. So that's it for this video. In the next video, we will see how to implement this topological sort algorithm with C++. Thank you.